I'm going to talk about outcoming pattern. So let's go to European weather model, or just Earth's history with it. So in Earth's history, when the like dust forms, like dust forms, and then the planets forms. First the dust forms, then the star is formed like our sun. Before that, before the dust came, the supernova happened. So when the Earth's history, Earth formed 4.5 billion years ago, then Theia formed and something this and Theia hit the Earth, Mars-sized object, a form blasted like parts of Earth and formed a ring, and then Moon. Gravity causes Moon to form, and then when the Earth cooled, volcanoes formed an atmosphere. The first one was the first. The first snowball Earth is caused by like decrease in greenhouse gases and reflecting sunlight and cooling the planet. The second snowball Earth was caused by like sun 170 million years ago. Was like greenhouse gas drop in greenhouse gases and volcanic activity decrease, which means less CO2 is released. CO2 released 770 million years ago to 635 million years ago. So how do you know this climate change is real? Because of ice cores. Also, how do you know the continent's moving? So like because of like fossils in the oceans, so in DNA and things. Radiometric dating, for example, like uranium 235 decays to 107. Well, like 107 uranium 235 decays. So radiometric dating. So when uranium like decays to uranium 235 decays to uranium 238, we can find the MS like Earth's like how old is like uranium 238 to lead 206 206 with half life of 4.5 billion years. So like when it decays, the uranium 238 decays to lead 206, and then releases half life of 4.5 billion years. So it's gonna take us lots of videos, future videos. So this alpha decay with the half life. Yeah, this also alpha decay. It's taking. So how did how did the Earth like out of 66 million years ago? I'm gonna check 66 million years ago. Dinosaur extinction caused by an asteroid. So it's like 15 kilometers, 10 to 15. So how did the warmest part of the Earth because of the solar? Oh, that's the warmest part of Earth's history is yet so warm. So it releases so much CO2 like primary methane and CO2, gases, because of thawing permafrost that releases methane, volcano activity. So CO2 is controls the climate, also the sun. When it's combined with CO2 and so CO2 and the greenhouse gases and the sun controls the climate. But CO2 traps heat and methane too. Greenhouse gases also trap heat, every greenhouse gas. So when the continents move, so South America, when this fossils South America, long like 250 million years ago, all the creatures from Africa to South America is going to be fossils. They move into South America, and when the land just moved, it's like Pangea split it, and then also the creatures like also like split it up. That forms today's continents. But 20,000 years ago, there was this grand song. There was this like sun, sun caused like little ice age, meaning like major ice age. There was this. Mm, there was the changes in Earth's orbit and volcano eruptions or from asteroid impacts like 20,000 years ago, like last glacial maximum. Volcano eruptions also causes an ice age 20,000 years ago. 20,000 years ago. So the climate is always changing. So in the future, like beyond 2025, it's gonna be like less weather changes, less natural weather changes, and less natural climate changes. But before humans, the climate is always changing, like ice ages to global warming naturally. So see you, yeah. This is also next ice age delayed if in yeah. So so precipitation pattern. 8 a.m. it gets nothing and this light rain showers and lake refresh. So 8 a.m. it gets no rain in Toronto and this Lake Huron could get some light rain showers. And like offshore Ontario could get some light rain showers. Ontario could get some light rain showers, like cloudy days. So London, Ontario could get some light rain showers. Niagara Falls could get some light rain showers. 2 p.m. it could get some light rain showers in Toronto, including the Stouffville around Toronto. So Peterborough could get some light rain showers. So light rain showers in Hunter, Ontario. Toronto to light to moderate rain. 8 a.m. we get some light rain in London, Ontario. Bloomberry, Ontario, nothing. So Toronto could get some light rain showers. Mississauga and Brampton could get. Mississauga could get some light rain. Morgan, Ontario could get some light rain showers. Orangewood could get some light rain showers. So gonna go fast. So so 8 a.m. is gonna be light to moderate rain, and Orange Ontario could get some light to moderate rain. So total rainfall in the next 5 days. So heaviest in the map is 36 millimeters of rain, and 17 to 15 degrees is in Toronto. Orangeville could get some rain, 20 millimeters, 21 millimeters of rain, or 17 millimeters of rain. Actually, like 14 millimeters of rain, around 14 millimeters of rain. Temperature pattern, temperature anomaly. This is just like air temperature, actual air temperature. So skip to Monday. I'm gonna skip the whole days today. So 7 a.m. is 13 to 14 degrees around Toronto. So Hunter, Ontario could get some 12 degrees. 3 p.m. is like 18 to 22 degrees. Hunter, Ontario is 19 degrees. Newmarket, Ontario could get around 21 degrees. 47 hours in this water model I meant. So it's like 14 degrees to 15 degrees in around Toronto. 13 degrees around Hunter, Ontario. Around Toronto it's like 90 to 27 degrees. 25 degrees Hunter, Ontario. 14 to 15 degrees around Toronto, including Toronto. So Hunter, Ontario is 12 degrees. 13 degrees, no, not 13. 17 to 25 degrees in around Toronto, including Toronto. So Hunter, Ontario is 21 degrees. 8 a.m. 13 to 14 degrees above freezing, 12 degrees above freezing in Hunter, Ontario. Toronto, it's gonna be like 13 degrees to 14 degrees. 8 a.m. in the mornings is gonna be 11 to 12 degrees around Toronto, including Stouffville. Hunter, Ontario could get 11 degrees, so fine. So Earth's tilt is also called. This is about the Earth's history continued. So Earth's tilt is also causing like colder climates. So when it's closer, it's like mag whatever is. Okay, I'm gonna skip that. So it's gonna be like Earth's orbit, like moving away from the sun makes the climate colder, or the sun, like grand solar maximum, like that's so sunspot compared to normal. It's gonna create a mini global, like partly warming in regional areas, like some parts of the world. But little ice age caused by like a sun or grand solar minimum is gonna cause partly cooling or regional cooling, like some places, not all. So there's gonna be so the beaker reflect the sunlight. Talking about technology now. So it's gonna be like there's gonna be like some kind of chemical release and block the sunlight and make the earth cooler in the future. So Venus was habitable for once, but the sun got too big. It's like billions of years ago. Yeah, billions of years ago. The Mars was habitable for once, but Mars matter feels like shut down.